20 years ago, it appeared for a moment that all of our energy problems could be solved. It was the announcement of cold fusion, nuclear energy like that which powers the sun, but at room temperature on a tabletop. It promised to be cheap, limitless, and clean. Cold fusion would end our dependence on the Middle East and stop those greenhouse gases blamed for global warming. It would change everything. But then, just as quickly as it was announced, it was discredited so thoroughly that cold fusion became a catchphrase for junk science. Well, a funny thing happened on the way to oblivion. For many scientists today, cold fusion is hot again.
We can wield the power of nuclear physics on a tabletop. The potential is unlimited. That is the most powerful energy source known to man.
Michael McCubry says he has seen that energy more than 50 times in cold fusion experiments he's doing at SRI International, a respected California lab that does extensive work for the government. McCubry is an electrochemist who imagines in 20 years the creation of a clean nuclear battery.
For example, a laptop would come pre-charged with all of the energy that you would ever intend to use. You're now decoupled from your charger and the wall socket.
Automobiles?
Same. Potential is for an energy source that would run your car for 3-4 years, for example, and you take it in for servicing every 4 years and they'd give you a new power supply.
Power stations?
You can imagine a one-for-one plug-in replacement for nuclear fuel rods. And the difference only would be that at the end of the lifetime of that fuel rod, you didn't have radioactive waste that needed to be disposed of.
McCubry showed us just how simple the experiment looks. There are only 3 main ingredients. First, palladium, a metal in the platinum family. Second, a kind of hydrogen called deuterium, which is found in seawater.
Deuterium is essentially unlimited. There is 10 times as much energy in a gallon of seawater from the deuterium contained within it than there is in a gallon of gasoline.
The palladium is placed in water containing deuterium, and the third ingredient is an electric current. So the experiment's running inside this box.
That's correct.
Can we open it up?
We can look inside. There's very little to see.
The experiment is wrapped in insulation and instruments. They're looking for what they call excess heat. In other words, is more energy coming out than the electric current puts in? No one knows exactly how excess heat would be generated in the experiment, but McCubry shows us what he thinks is happening.
This is an artist's rendition of deuterium atoms.
At the atomic level, palladium looks like a lattice, and the electricity drives the deuterium to the palladium.
They sit on the surface and they pop inside the lattice.
McCubry believes there is a nuclear reaction, possibly a fusion process like what happens in the sun, but occurring inside the metal at a slower rate and without dangerous radiation.
What we're trying to do is...
Scientists today like to call it a nuclear effect rather than cold fusion. At least 20 labs working independently have published reports of excess heat. Heat up to 25 times greater than the electricity going in.
This little piece of palladium metal has about 1/3 as much energy as the battery in your automobile. So very small volumes, very small masses can produce large amounts of energy.
McCubry has been working on this since that first discredited claim of cold fusion made headlines 20 years ago.
We devised an experiment.
Martin Fleischmann and Stanley Pons amazed the world in 1989 with their cold fusion news conference at the University of Utah. Fleischmann, in particular, was one of the world's leading electrochemists, and the announcement of room temperature fusion set the world on fire.
We have found conditions where fusion takes place.
Immediately, prestigious labs at MIT and Caltech rushed to reproduce the experiment, but they didn't get the same results as Fleischmann and Pons.
We have no evidence in our laboratory with any of our samples for fusion.
The careers of Fleischmann and Pons were destroyed quick as a nuclear flash.
We worked for 5 years on this.
Names once linked to a Nobel Prize were forgotten by nearly everyone, and most of the scientific world today is happy to leave it that way.